Hi everyone, welcome to my channel Code with Ease by Varsha. Today we are going to solve this question, implement a queue using stack. So far as part of stack and queues playlist, these are the two questions that we have already covered, how to implement a stack using a linked list and how to implement a queue using an array. So today's question is also going to be some playing around with the data structure of queue and stack. So over here, what we need to do is we need to implement the FIFO queue using the stack operations, the push, pop, peek, and t. So the operations will be the stack APIs or the stack methods. The names will be of that. But the actual operation should behave like it is happening in the queue. The push operation should work like a push of a queue. The pop operation should work like a pop of a queue. So we'll do a dry run and we'll see an input output example of what that means. But let's try to go through the problem statement once. So we have to implement this FIFO queue using two stacks. So we can make use of two stacks and we will see why do we need that, and we have to implement the myQ stack. These are the bunch of operations that we need to do. Now push, pop, peek, these are very simple operations. Those of you have, so if anyone doesn't know, just watch the previous videos or just read about stack in general. Push means adding an element to the stack. Pop means removing an element from the stack. Peek is just to see which element needs to be popped to remove next from the stack. And empty is simply just a check of the empty. These are the different bunch of operations. Now these operations will remain the same just as it behaves in the stack. The only difference is now these operations output should be on the basis of a queue. When you do push is fine, but when you do pop, the element to be removed will not behave like the element to be removed in case of a stack. So let's move to the white. Okay, so continuing from what we were saying, let's quickly take an understanding of what the stacks operation and what the queues operation will look like. See, if I'm trying to push an element to a stack, suppose I am trying to push 1, 2, 3. And similarly, I'm pushing 1, 2, 3 to my queue. So far, so good. Now, if I want to remove or if I want to do a pop, 3 is going to be the element which will be popped in case of a stack. In case of a queue, if I want to do a pop, or the actual name of the operation is DQ and NQ in case of queue. But anyway, if you do a pop in case of a queue, the element which is going to be removed is not 3 but 1, because it is the behavior is FIFO. Whatever went in first, that will be the first element to come out. And in case of stack, it is LIFO. So now our main challenge that we have is we are being given two stacks. We can make use of two stacks. Okay. Now using these two stacks, we have to ensure that when the push happens, okay, it will happen just the way it happens normally. When the peek and the pop happens, the element that needs to be removed, the next eligible element, should not be the last one. It should be the first element itself. And all of this we have to ensure using the two stacks that we have taken. That's it. So let's say I call it one as the input stack and another one as the output stack. And let's see how can we do this. So first, let's talk about the push operation. Push is as simple and as same as what you have in stack. So how would you, as same as in stack. So how would you actually add in a stack? You would say, suppose this is my input stack. I'm naming it as input stack, and then you push whatever the value is. That's it. You push into a stack. Of course, so push is done. Push is done. Now let's talk about the pop operation. So like I said, in case of queue, how the pop will be, the first element will be removed. Now you think about this. I have two stacks. So I have this input stack. I'm not sure why am I writing like a queue, but anyway, just think of it as two stacks. So I have input stack, I have output stack. So I've pushed one element into my input stack. Similarly, I've pushed another element into my input stack. Now I want to do a pop operation. So when I'm doing a pop operation, what should be my output? In this case, my output should be 1 because 1 went in first. But I am only having the stack APIs and methods. The access I have to only is the stacks API. So if I do stack input stack dot pop, I will get 2 no matter what I do. What should I do so that I can get 1? And that is where I have to make use of this intermediate or the output stack. What I am going to do is I am going to reverse the element, reverse the order of elements that has been pushed in the input stack from here to here. So the condition is going to be while the output stack is empty, because if it is having elements, then you don't have to do it. While it is empty, then you transfer the elements from input stack to the output stack. That will cause the reversal, like 2 will be transferred, then 1 will be transferred. After that is done, then you do output stack pop it out. So over here what it will be, 2 will come, then 1 will come, and I'll pop. If I pop from the output stack, what will be popped? My element 1 will be popped. These are the 2 steps that I have to do. While output stack is empty, transfer elements. This will be like a generic method, transfer elements method. Don't worry about the code. Code is already available in the GitHub. So in the description, you can check it out. And from the output stack will pop. So what will happen is when your output stack will not be empty also. Suppose you already have elements. And second time you want to do a pop operation. Then you don't have to do the transfer elements. Then automatically you just have to do output stack.pop. That's it. This is the story of the pop operation. How are we achieving it? We are making use of the intermediate stack, reversing the order of elements and accessing the last element from the output stack. We are not touching the input stack, remember. Now let's talk about the peek operation. What is peek? Peek is similar to pop, it's just that you are not removing, you are just seeing the element. Just seeing the element which will be popped if it is eligible. Same logic that you have. So instead of doing a pop, you just have to do the same, like while output stack is empty, you will transfer the elements. This much you will have to do. And second step is your output stack dot peek. Instead of removing, I will just peek. Peek is also done similarly. Next is the empty. When can I check that my queue in the form of a stack is empty? I have to check if my input stack is empty or not first. Okay, I have to check if it is empty or not. I also have to check if my output stack is also empty or not. Because it might happen you have done a transfer elements. Only if two stacks, input and output stack, both are empty is when I'm going to return true from this is empty method of the queue. So we have covered push, peek, pop, empty. Is there anything else? No, that's it. So these are the methods that we have to cover. The code is already available. It was a very simple thing, but it looks like so many lines of code in the problem statement. It looks very intimidating to many of the readers. It looks very intimidating to many of the coders, but it is not so. See, it is so simple. All you need is to understand the logic of how to initialize the two stacks and how to make the transfer elements, how to write the logic for this transfer element. So I'll also just quickly brief about that. So what will be the logic for transfer elements? It is very simple. While your input stack is not empty, like while it is not empty, you keep on popping elements. So you just put output stack dot push into the output stack. Whatever you get from the input stack dot pop. That's it. You keep on doing that until your input stack is not empty. Once it is empty, you obviously don't have anything to pop from the input stack. So this is going to be the logic of transfer elements, which we are going to make use of over here and over here. That's it. So this is all about the question how to implement a queue using stack. In the next video, we'll try to bring more questions on stacks and queues. Thank you so much for watching this video. Do like and share.